So, the multiple choice questions. Question 1. Which statement about pH is correct? The pH of a weak base is independent of temperature. Absolutely false. It is dependent of temperature. As temperature changes, so will the pH. At temperatures above 298 Kelvin, the pH of pure water is less than 7. At temperatures above 298 Kelvin, well, because making pH of pure water is less than 7, making H plus ions is an endothermic process, and temperatures above 298 Kelvin, well, there's going to be even more H plus ions, or concentration H plus ions, at temperatures above 298 Kelvin. So what's that going to mean? That means the pH is going to be less than 7, so therefore it is correct. Question 2. What is the pH of that of a diprotic acid? Diprotic acid so releases 2 H plus ions. So what's the pH of that? Diprotic acid completely dissociated. So what I have to do first, I need to times that by 2, and that will give me 0.040, and that is the concentration of H plus ions. And therefore I'm going to do pH equals minus log 10 concentration of H plus ions minus log 10 0.040 1.40. However, if I just did pH minus log 10 0.020, I'd get 1.70. But that's wrong. We need to times it by 2 since it's a diprotic acid. Question 3. What's the concentration of sodium hydroxide? Sodium hydroxide is a strong base. Not really important, but yeah, say it. Has a pH that. Kw is at that. So first things first, I'm given the pH, so I can use concentration of H plus ions equals 10 to the power minus pH. Concentration of H plus ions equals 10 to the power minus 14.30. Now, ionic product of water, we're given Kw. We're going to have to rearrange the expression. Kw equals concentration of H plus ions times by the concentration of OH minus ions. We want to find the concentration of OH minus ions, so we're going to have to do OH minus equals Kw divided by concentration of H plus ions. Kw is given in the question 1.0, and if it isn't given in the question, it's going to be 10 to the power minus 14, 9 times out of 10, divided by your concentration of H plus ions, which is at 10 to the power minus 14.0, just using that simple expression. Concentration H plus is 10 to the power minus pH. 1.0 times by 10 to the power minus 14 divided by 10 to the power minus 14.30, I get 1.995. So 2.00. It's a bit confused, I can't see 1.995. 2.00 is the correct answer. Question 4. What is the pH of this potassium hydroxide? Now, when they don't give you, like the previous question, they gave us it was sodium hydroxide. We knew it was it only had one OH minus ion. If it doesn't give it you, always try to write it down, because sometimes it can have 2 OH minus ions and try to trick you out. In this case, no, it's just one. What's the pH of this? So what I have to do is Kw, ionic product of water again, equals H plus OH minus. I want to find the pH, so I need the H plus. H plus equals 1.0 times by 10 to the power minus 14 Kw given in the question, divided by OH minus 0.46. And then I'm going to use pH equals minus log 10 concentration of H plus, and all I'm going to do is substitute what I get into there. So first find out what H plus is. 1.0 times by 10 to the power minus 14 divided by 0.46. pH is minus log 10 of my answer. pH equals 13.66, always to 2 decimal places, remember, for pH. So the answer is B. Question 9. Which one of the following is a change in units of pH which occurs when 10 centimeters cubed of a strong monoprotic only reaches 1 H plus ion acid made up to that much with water? Now, if you find out the change in the pH, so if you find out the pH originally, pH is minus log 10 of my H plus 1.0, I'll get 0. So I'm going for a pH of 0 to what? Well, I need to find that out. Well, after that, the dilution has been made up to that, what happens is that I go from 10 divided by, it's the original volume divided by, yeah, exactly. It's to find out the dilution factor, what I need to find out, dilution factor in this case. And I'm confused why this asked me for 1 marker, but it clearly can't be too hard since it's only 1 mark. It's going to be the original volume divided by total volume. And here's the tricky part that I fell for. Obviously that is 1000 centimeters cubed, so 10,000 divided by 1000 plus 10, right? Because the total is going to be 10 plus that. But if you read the question properly, it says are made up to that with water. So that means the total is 1000 centimeters cubed, aka 1.0 dm cubed. That's the total that is made up to it. So it's actually 10 divided by 1000 in its correct units. 10 divided by 1000, 0.01. And that is the dilution factor. We're timesing by 0.01. Right? So what happens to the pH? Well, the pH is minus log 10 of my answer, 0.01, which is 2. Because remember, that is obviously the concentration of H plus ions, since it's a strong monoprotic acid. We can assume that's a concentration of H plus ions. So what's the change in pH? 2. That is a very tricky question in my opinion, because it's not your classic question. It's not like I give you one value and I want you to use some information to calculate another value and therefore find out another value. It's more like you need to know this formula. You also need to read the question properly. Which one of the following is changing units pH when it occurs when 10 centimeters cubed of that is made up to that? So original volume 10 divided by total volume 1 dm cubed, aka 1000 centimeters cubed, 0.01, we times by 0.01. Find the pH at the beginning of a 1.0 solution, pH minus log 10 of 1.0, that's 0. Then do pH minus equals minus log 10, 0.01, that was 2, therefore the change is 2. Tricky, very tricky. And then question 10, the pH of this at 25 degrees Celsius is sodium hydroxide. Well, we're going to have to use ionic product of water. Kw equals concentration H plus OH minus. We want to find pH, we need concentration H pluses. It doesn't give us ionic product of water, Kw, in this question, but it's at 25 degrees Celsius. It's 1.0 times by 10 to the power minus 14 divided by 0.001. It's clearly only got one OH minus sign, so we don't need to worry about that. If I put that in the calculator, 0.001, I get concentration H plus ion equals 1 times by 10 to the power minus 11, but that's not the final answer. I need the pH. Well, pH equals minus log 10 concentration of H plus ions. Just substitute that into there. So minus log 10 of my answer. I should get pH as 11. Now let's mark it. Question 1b. Question 2b. Question 3d. Question 4b. question 9b, question 10b, the two hardest, question 9 and 10 in my opinion. Question 9, original volume over total volume, find the dilution factor, and then use pH minus log 10H plus. You go from 0 to 2, therefore change pH is 2, and hopefully you found it useful.